Alright, is this slide visible to you?
Yes, sir.
Okay, let us start our today's lecture, and this is our week. We are in week number 12 at the moment, and this is our lecture number 12.1, in which we would be dealing with numerical control, NC, and CNC, which is computerized numerically controlled machines, and its programming. So we would be discussing the theoretical part of the CNC machines and CNC programming also today, but I'm going to give you some knowledge about a CNC simulator in tomorrow's lecture, and you will be given an assignment also to write down a program and run it on the CNC simulator. So as far as today, we will be only dealing with the theoretical part of the programming, in which we would get to know that how a CNC program is written and how is it, how does it execute. So that will be seen through the simulator after tomorrow's lecture. So today we have two parts of our lecture. Part one will deal with the numerical control machines. We will be talking about the machines, and in the second part, we will be carrying out a part programming using the G and M codes. You must have heard probably you must have heard G and M codes, which are used for CNC machines programming. So we would be familiarizing today with the GNM codes and how to write down a part program. So this would be the part 2 of our lecture today. So let us move on to the part 1, which is numerical control, or CNC. So how do we define numerical control? So numerical control is a form of programmable automation. So we are familiar with programmable automation. We are familiar with this term, programmable automation, and in which the mechanical action of a machine tool or other equipment are controlled by a program containing coded alphanumeric data. So alphanumeric data means that it is going to have some alphabets plus some numeric values. So we would be looking at this alphanumeric data, which is a code which can run a program onto our machine, onto our CNC machine, and it can carry out some manufacturing process or a machining process for us. And we know that this is a part of or a form of programmable automation. There were other two types of automation. Just a recap for you who probably did not attend the last lecture. So we had two more automations, which were, can anybody name those? याद है किसी को कि what were the other two? If I gave this as number 1, so what would be the second one? We talked about fixed automation, and in between the fixed and so this is number 3, we have flexible automation. So I'm not going to go into the details now. These names sound some bell, ring some bell into your mind, and you would now exactly know that how this can be a form of programmable automation. Alright, the alphanumeric data represents the relative position between a workhead. So definitely it means that we need to give a reference point to our tool to move to another location. So it means that we need to give it a data, and that data is actually given as a relative position and in the form of Cartesian coordinates. So we would look into it in more detail when this lecture progress. So there is a relative movement of the workhead between the workhead, which is the cutting tool, and the work part. And when the current job is completed, a new program can be entered for the next job. So a new program, entering of a new program is actually the part or the form of programmable motion. So this is the word which leads to programmable automation. So in fact, when one job is completed, so you put another program into your machine, which is written in the form of that alphanumeric data or G or N codes, and then you can run that program and make another or a different workpiece according to the program. So this is how the numerical control is defined. So it can be applied to a wide variety of processes and the machine tool applications such as drilling, milling, turning, and other metal work. So see, these are the machines which you have been dealing with while you carried out the workshop practice module or the workshop practice subject. So these machines which can carry out drilling, milling, turning, or other metal works. So these are the machine tool applications, and these are the processes which can be carried out with the help of CNC machines also. So then the non-machine tool applications such as assembly, drafting, and inspection. So that can also be carried out with the help of a computerized numerically controlled machine. So how can the inspection be carried out with a computer? Can somebody throw some light on this?
सर लेजर से इंस्पेक्शन कर सकते हैं.
Very good. So you can use the laser to find out the distance, or find out the measurement of a piece, or maybe you can find out the discontinuity or continuity of a piece. So let's see if there can be an application like this if we talk about the laser. So in fact, let's see if you have a part like this which has a groove here. So with the help of the laser light, if you have a laser source underneath this, if you have a laser source which is underneath this part, so it can give you the dimension or the correctness of this groove. So this can be, if that groove or this is through and through, then the laser can be used for this. Or maybe the inspection can be done with the help of a camera also. So you can probably use a camera to have a photograph or of the part which you have made, and then it can be analyzed if the quality of the surface or something like this is good enough to pass that object. So this is how the inspection can be done automatically with the help of any CNC machine application. Now, what is the basic concept? So the basic concept of the NC system is, number one, part program of instruction, which is part programming, and this is, we have already discussed that it is in the form of alpha numeric code. So we have an alphanumeric code which is used for the part programming. Then we have the machine control unit which controls the processes. Or so what that can be, the things which can control the process. This can be a computer. This can be a microprocessor. Or maybe it can be a teach pendant. So there can be these kind of machines, or these can be this type of machine control unit which actually controls the process. And which is that process which is being controlled? It is the machine tool control, and it is the machining process which is controlled by these units. And what are the processing equipments which perform the processes, and what type of processes are those? We have already talked about it. Those can be something like drilling, turning, and many other processes. So these processing equipments, these machines, which are drilling, turning machines, they are controlled by a machine control unit, which is a computer, which can be computer, a microprocessor, or a dependent, and these controls, they come from the alphanumeric code, which is written in the computerized numerically controlled machine that we help with an operator, with a programmer, and then these instructions are carried out with the help of machine control unit. And then the processing equipment, these are controlled, these are the processes are performed, and we find out um, a finished product which comes out. So whatever we have discussed until here, this is shown here with the help of a diagram. So as I said, the first process, your first step is to write down a program. Then that program in the second step goes to the machine control unit, which gives instruction to the processing equipment, which gives instruction to the process equipment, which is step number 3. And then the processing equipment carries out that task, or carries out that movement according to the program which is given to the machine control unit. And then there is a feedback also coming here. So the instructions are going to the machine, and then the feedback is coming also towards the machine. So it means that when you give one instruction to the machine carries out that instruction. Then the next instruction is carried out with the help of the machine control unit, and then there is a feedback also, in which you can see that the processes are being carried out in a certain fashion, in a certain sequence, which is required, and in which sequence the program was written. So this is what is the concept in the form of a picture. So as we talked about that, while we are writing down the alphanumeric code or GRM code, so we would be actually dealing with Cartesian coordinate system. So these are called NC coordinate system, which are used for the machine. And let us just look at this, that for a flat and prismatic block like parts. So if this is a block like part, this is a block like part, and it is being placed on the work table here. So the work part is a block like part as uh, given here. So it is placed on a work table, and that work table can rotate and can move in 6 directions. So these are actually this is being used for the milling and drilling operations, and these are the conventional coordinate system. So rotational axis about each linear axis, and the rotation is according to the right hand rule. So we are familiar with all this, so we do not go into the details. So this is just a bigger, a larger picture, or an enlarged picture of the NC coordinate system, in which we have 3 axes, 1, 2, and 3, and then rotation about these axes. So this is rotation about X, rotation about Y, and rotation about Z. Okay जी कोई यहाँ तक, if you have any question until here, or if it is clear, so we move forward. Okay, so these were the NC coordinate system for milling and milling machines, and now for the rotational part, the NC coordinate system for the rotational part is rotational parts is actually for the lathe machine. So you people have used lathe mill machines while you carried out your while you studied your subject of workshop practice. So the lathe machine is used for turning operations, the conventional Cartesian coord system, but only X and Z axis. So Y axis is not needed. So in fact, there are only 2 axes for a lathe machine, in which the work part rotates about z-axis, and the tool, either the machine tool moves in this direction, which is the z-axis direction. This is used for turning. Okay, this axis is used for turning operation, and our arm tool can also move in x direction, which is used for depth of cut. Okay, so this is shown in this orientation, but actually on a lathe machine, you know that the part is mounted like this. So this will be my z axis, which is going to give me the turning, and this is the x axis, which is going to give me the depth of cut. ठीक है जी, so this is for the lathe machine, and previously we have seen for the mill and drill machine, and this is the again the enlarged portion or zoom out portion of the picture of the lathe machine axis. जी, ये एक्सिस आपको क्लियर है? कोई सवाल यहाँ पे? जी, is there any question? Please somebody to respond.
No, sir, it's clear.
Okay, so it means that this is clear and up till this point. So let me just go into a little more detail now. That let us see a mill machine which has 3 axes. So on your right, you can see a mill machine. You can see a mill or a drill machine in which this table. This is your work table. This is your work table. Which can move into 3 directions, which is X, Y, and Z. And just to give you an idea, that the axis which is going into the machine, will always be termed as Y axis. So the axis which is going into the machine will be always termed as y axis. Okay, and then there will be 2 perpendicular coordinates. There will be 2 perpendicular coordinates of which will be x and z axis, which will be perpendicular to y, and they will be perpendicular to each other also. So this is how a mill machine would look like. And if we see here on the picture on the left, so you would see that we have the y-axis which is going into the machine, then an x-axis which is turning this work table, which is moving this work table, and then the y-axis in which either the table would move, or maybe the tool can move in the y-axis. So let's see, for a drill or a mill machine, the tool can move in up and down, which is in the z-axis, and the table can go into the machine like y-axis, or it can move in the x-axis direction. So this is how a 3-axis mill would look like. Anybody who has an idea of more than 3-axis machine? 3-axis, so we are clear that this work in Cartesian coordinate system. So what would be a more than 3-axis mill machine?
सर 5 एक्सिस होती हैं.
5 axis होती है. So what would that mean, 5 axis? From where the other 2 axis will come?
उसमें एक तो टूल हेड मेरे ख्याल से रोटेट कर सकता है.
Okay, so in fact this is the let me just show you this. So this is actually the rotation about any of the linear axis. Okay, so if you look at this, so this is a 5-axis mill machine. So these are the Cartesian coordinates, linear axis, which we have discussed earlier, which is y-axis, x-axis, and z-axis. And now see, either the tool or the table on which you have fixed the I mean, you have fixed the work part. Now it can rotate. So this is A axis. So A axis is rotation about X axis. And then B axis. B axis is rotation about Z axis. And if this can be turned or into the rotation about Z axis, so we can have a 6-axis mill machine. Okay. So one thing is for sure that with more than 3 axis mill machine, the complicated parts can be made, the intricate parts can be made, but adding an axis to the machine would add to the cost of the machine. So you would see that the 5 axis or more than 3 axis mill machines, they will be used for specified or very intricate parts to be made. So let me just give you an example. Now, are we now clear that how the other 2 or 3 axes can be added to the machine?
Yes, sir.
Ji,
Yes, sir.
okay, that's great. So if you're clear, so let me give you an example here. So this is a video which you can see. Uh, so this is this is an impeller. This is an impeller of a turbine which is being cut on a 5 axis mill machine. So you can now see that the work part is being moved with the help of 5 axis machine, and this impeller is being cut. So these kind of intricate parts, these are being used. These are being manufactured with the help of more than 3 axis mill machine. So the 3 axis mill machine cannot make you an impeller of the turbine because इसके अंदर जो curves involved हैं manufacturing की, those cannot be made while using the 3 linear axis. So now you need to have 2 more axes to give these curves to move or rotate the work part about X and Y axis to get this. So this is how a 5 axis machine would work, and you can have an idea that what type of um, um, intricate shapes or products can be made with the help of 5 axis mill machine. So let us move forward, and this is just a reading assignment that how many axes the conventional lathe machine would have. We have already discussed its answer. So can somebody let me know that how many axes the conventional lathe machine would have?
Sir, three maybe.
Conventional lathe machine would have how many axes?
Two.
2 axes. Okay. Which one? Which were those 2 axes?
X and Z.
X and Z axes.
Radial and.
जी बिल्कुल ठीक है. X and Z axes. So Y axis is not required for a conventional lathe machine. ठीक है. So we have already talked about this. So the reading assignment goes here with the answer. So we know that now that a conventional lathe machine would have 2 axes, X and Z, and Y axis is not required. So let us move forward and now talk about the motion control system. So we have talked about the machines first, that what type of machines would be used, and now we are coming back to the part which is before the machine, that how the machine control unit is going to control the motion of the tool. So there can be 2 systems in which the motion of a tool can be controlled. So these can be a point-to-point system and a continuous path system. So what would be a point-to-point system? This is also called a position system. The system moves to a location. By system here, I mean that the tool will move to a location and performs an operation at that location. Maybe that can be drilling. We will look into it with more details. I'm just giving you an idea that from point to point we mean that if you look at my hand, so let us see if this is the work this is the work table or this is the work part. So we will have a drill machine which is going to move from one place to another. So this is point to point motion. So x and y coordinates given here, and then x and y coordinates are given to an of another point, so it moves here. Then x, y, and z coordinates are given, and then it moves down. It moves down and it goes through this part and actually carries out a drilling operation. So this is what is point to point movement. So while it is moving from one point to another, it is carrying out it moves from one point to another, then carries out a drill operation, then comes out and goes back. And then there is a continuous path operation in which probably we need to cut a groove into this system, into this machine. So what would my milling cutter would do, that it is going to go into this, and then it will move like this, and it is going to carry out the cutting operation, or making a groove that can be milling. And if in case of lathe, while moving the tool with the in the z-axis direction, if we are talking about lathe, so it is going to carry out a turning operation. So let me just show you these in the form of a picture. So let us see. This is the x and y coordinate, and now if you look at my hand, this was my work part. So now I'm looking on from the top. So I'm looking from the top at my work part. So this is the top view here. Actually, this is the top view of the machine. So this is the top view of the machine, in which I can see that there is a part being placed onto the machine, and we need to carry out 1, 2, and 3 drills. So these are the 3 drilling operations. So my tool will be given a reference here. So tool will start moving from this place, and let's see, these are the arrows which are depicting the tool path. So this is moving with the as we feed in the coordinates x and y. So this point will have an x and y here. So then we will move to the location at point 1, where we want to drill a hole. So this will have a x and y coordinate first, and when we carry out the drill, so actually we are going to give it a z value also. So it will be given a z value, so that if you look at my hand, so this was the top view. Now you can see. So here was my drill machine, which you can see with this pen. So this is going to go into the part to carry out a drill. And if I move it like this, so this is the top view now. So it is going to go and carry out a drill in this part. So this is how the point-to-point system. So the movement from one point to another, like from point to point 1, carry out an operation, that move to point 2, carry out another drilling operation, then move to point number 3 and carry out the drilling operation. So this motion is called point-to-point system. G. Any question? Are we clear?
Yes, sir.
Okay, that's great. So this is the continuous path system. So what do we mean in the continuous path system? That the moment the tool comes into contact with this is the tool, this is the cutter, this is the milling cutter, and mind you, this is again the top view. Let me just write it down. So this is again the top view. So I'm looking at my workpiece from the top, and my milling cutter is moving around my part. This is my work part, and see, throughout its movement, it is carrying out a machining operation, which is actually removing of material or cutting. Okay? So that is why it is called a continuous path system. So during the motion control system, in which we are using the continuous path system. So in that system, the tool carries out a process while it is moving around or moving into the work part. So this is called continuous path system. Okay, so let us move forward and now talk about that what type of these operations or what type of these movements can be termed as, these can be termed as interpolation methods. So let us see, let us first see the linear interpolation. So linear interpolation means that we are carrying out some cutting process or metal removing process while our tool is moving in linear direction. Let's see how would that be. So let us see that if our tool moves from this location to this location, this is location number 1 and this is location number 2, and by this cross I mean the center of the tool is mentioned by this cross. So the center of the tool is actually mentioned by this cross. So it is moving from point number 1 to point number 2, and since it is moving in a straight line, so let's see the straight line, this is the straight line between the 2 points in space. So this is called linear interpolation. Okay, similarly we can have a circular interpolation also. What would happen in a circular interpolation? That our tool is going to move into a curved path. Okay? So my tool is moving from point number 1 to point number, let's see, मैं arrow से दिखा दूं कि किस direction में motion हो रही है, and moving to point number 2. So this is called circular interpolation. So a circular interpolation would be defined by a starting point. Okay, this will be defined. Let me just take the other color, please. So this would be defined by a starting point and by an end point. Then the center or the radius of the curvature which we want to achieve, the arc which we want to make, and the direction of motion also. See, so these are 4 things which we need to know, or we need to give input to our machine to carry out a circular interpolation. So starting point is point 1. So this is the starting point. This is the end point. Right, then there is a center, which is then there is a radius of curvature. So this is actually the R, which is the point number 3, and the direction. By direction I mean that either it is counterclockwise movement or a clockwise movement. So in this, probably in this motion, we see that this is a clockwise motion. So either it means that if we are cutting an arc, if we are carrying out a circular interpolation, so we need to mention that either this motion is in the clockwise direction or this motion is in the counterclockwise direction. So this is how the linear interpolation and the circular interpolations can be explained. G, clear?
Yes, sir.
Okay, that's great. So let's move forward. And now, since we have talked about the positioning, so the positioning would mean that I need to give my machine some positioning system. Okay, we have talked about it earlier, and we talked about that the positioning system would be related with the Cartesian coordinates. Okay, good enough. Now, how do we need to give the position to my machine tool to move from one place to another? So there can be 2 methods which are used. So one is the absolute positioning method. So location would be defined relative to the origin of axis system. We will explain, I'll explain it in the next slide also. So it means that here you can see for an absolute positioning system, there is going to be one origin of axis. Let's see, this is the 0, 0. ये जो मैंने आपको अपने अभी, you can see my hand with the 2 axes shown. So this is the x-axis and this is the y-axis, and we have the origin here. So let's see that in an absolute positioning system, we use this origin as the reference point, and all the dimensions and all the position points given in XY with reference to the origin. So this is called absolute positioning system. The incremental positioning system is that the locations are defined relative to the previous location. For example, I'll just look at this. मैं जरा आपको मेरे हाथ की तरफ देखिए. If this is my X and Y axis, and from the origin, the tool has moved to this position. So this is the first position, your first point in XY, which is given a reference with respect to the origin. And if I I want to move my tool to another location. So I can give this location by two systems. Either I give it XY from the origin, so that would be the absolute positioning system. Or maybe I can give it a position from this position to the next, which would be the incremental position. So these are two types of positioning system which we can use, the absolute positioning and the incremental positioning. So let me just explain it to you further. So look at this here. So we have an origin here. We have an origin here which is 0, 0. Okay? Now, with the help of this 0, 0, this is 2020. So this is my position number 1, and this is in absolute. मैं इसको absolute positioning AP लिख देता हूँ. So this is absolute position with respect to 0, 0, and then is 40, 50, which is the second point, and this is again an absolute position. ये बात समझ आती है? जी जी ये एब्सोल्यूट पोजीशन वाली बात तो समझ आती है, ये तो हम पहले कर चुके हैं. सो व्हाट वुड बी द इंक्रीमेंटल पोजीशन सिस्टम? सो द फर्स्ट पोजीशन which will come here, which is 2020, would be given to my tool from the origin. So its previous position would be 0, 0, and the next position would be 2020. Okay, now what happens if I'm using the incremental system? So इस 2020 पे पहुंच के वो इसको consider करेगा कि now this is 0, 0, and मैं इसको I'm giving it a name of incremental positioning system. So it will consider this 2020 as 0, 0, and then it will move to this location while considering the previous point as 0, and it is going to move 20 and 30. So this will be, the second point will be actually 20 and 30 in incremental positioning system. So what I want to tell you here is that I need to tell my machine that either I'm using the absolute positioning system or I'm using the incremental positioning system. So accordingly, I have to, while I'm making the program of my of the machine, so I need to write down the coordinates as per the instructions given to my machine, that which type of increment or which type of positioning system I'm using, either absolute positioning system or incremental positioning system. जी मुझे बताइए यहाँ तक कोई सवाल? If you please do ask me if you have any question until here. And if there is no question, please somebody to respond that the things are well understood until here.
सर जानने के एब्सोल्यूट पोजीशनिंग में तो ठीक है, हमने मूवमेंट किया, तो अगेन इसको हम किस तरह रिलेट कर रहे हैं एक दूसरे को, एब्सोल्यूट इंक्रीमेंटल को थोड़ा सा?
ठीक है, एब्सोल्यूट और इंक्रीमेंटल को हम रिलेट कैसे करें? दिस इज योर क्वेश्चन. ओके, सो एब्सोल्यूट में आप देखो तो ये जो मैंने आपको रेड बना के दिए हुए हैं इस वक्त, लेट मी जस्ट एक मिनट में ना इसको भी रेड कर लूं ताकि ये और क्लैरिटी के साथ आपके सामने आ जाए. सो दिस इज एक्चुअली, ये इसको मैं रेड कर रहा हूं. ओके, सो एब्सोल्यूट पोजीशनिंग सिस्टम क्या है? ये एब्सोल्यूट पोजीशनिंग सिस्टम वो है जो कि हम अपने नॉर्मल रूटीन में यूज करते हैं कि we have an origin 0, 0, then we have a point 20, 20, and we have a point 40, 50. So ये जो दोनों points हैं, these are taken with the reference here. Now come on to the green ink which I've used. So my first point would be 2020, but since I have told my um, machine that I'm going to use the incremental system. So what would my machine do? When it moves to 2020, so in fact, the previous position was 00 here. अगर मैं green की बात करूं, तो green part में again इसकी जो पहली पोजीशन थी वो 00 थी टूल की. मैंने उसको 2020 का एक रीडिंग दी, so it reached here, इस पोजीशन पे आ गया. अब यहां से वो इसको 00 कंसिडर करेगा, और अगर मैं उसको कहूंगा कि अब 2030 मूव कर जाओ, तो इट इज गोइंग टू मूव 20 units in x-axis and 30 units in y-axis with reference to this now, the previous point, which is this point, and it moves to 2030. And from here, if I ask my machine to move 10 units in, let's see, 10 units in x and 10 units in y, so this will be again taken as, this will be taken as 10 by my machine. This will be taken as 10 by my machine if I am talking about, so it reaches here. So see, अब उसने क्या किया, पिछले वाले को फिर उसने 0 ले लिया, ये रेफरेंस ले लिया, और यहां से 10 मूव किया. बट अगर इसी कंडीशन में मैं इसको एब्सोल्यूट पोजीशनिंग सिस्टम में लूं, तो इस पॉइंट नंबर 3 के क्या होंगे, कोऑर्डिनेट्स क्या होंगे पॉइंट नंबर 3 के, जी बताइए, पॉइंट नंबर 3 के कोऑर्डिनेट्स क्या होंगे एब्सोल्यूट पोजीशनिंग में? दिस वुड बी 50 एंड 60. ठीक है, तो ये फर्क है एब्सोल्यूट कोऑर्डिनेट में और इंक्रीमेंटल. अच्छा, हम इंक्रीमेंटल कब यूज करते हैं? हम इंक्रीमेंटल उस वक्त यूज करते हैं व्हेन वी हैव अ वेरी वेरी इंट्रिकेट शेप, जिसमें एक पॉइंट से दूसरे पॉइंट के दरमियान डिस्टेंस भी थोड़ा है, ऑपरेशन भी है, देन अगेन फिर ऑपरेशन है. फिर जैसे आपने देखा कि हम कट कर रहे थे इम्पेलर को, you have seen that video in the previous slides. So we were cutting the impeller. So while we are making some intricate shape, so we shift to the incremental coordinate system, ताकि वो फिर उसको फिर reference के साथ हमें, तो this is ease of programming. This is ease of programming that we shift to the incremental positioning system. जी ठीक है, is this right? Now have you understood this?
Yes, sir. Sir, break का कुछ आंसर?
ब्रेक लेना चाह रहे. अच्छा, इसको क्योंकि इसी को मैं बिल्डअप कर रहा था आगे, तो ब्रेक पे फिर ये होगा कि थोड़ी सी डिसकंटिन्यूटी आ जाएगी. सो आई वाज ट्राइंग टू बिल्ड इट अप फ्रॉम हियर, कि अब मैं थोड़ा सा प्रोग्रामिंग की तरफ जाना चाह रहा था. सो आई थिंक थोड़ा सा आई विल स्लो डाउन एंड कीप मूविंग इंस्टेड ऑफ टेकिंग अ ब्रेक. ठीक है जी. सो okay. So next step we are now talking about the computerized numerically controlled machine. So the system which we have studied, that the numerical control machine, so it becomes a computerized numerically controlled machine when we involve a machine control unit or a dedicated, we involve an MCU, which is a dedicated computer rather than a hardwired controller. हार्डवायर कंट्रोल एक्चुअली क्या होता है, दिस इज अ टीच पेंडेंट. वो आपने देखा होगा कि यू हैव अ पेंडेंट, अगर आपने कोई मशीन ऐसी ऑपरेट की हो, सो पेंडेंट होता है, उसके साथ एक वायर लगी हुई होती है, और वायर के बटन्स के साथ आप उसको कंट्रोल कर रहे होते हैं. सो दैट इज कॉल्ड हार्डवायर्ड कंट्रोलर. बट माइक्रो कंप्यूटर कंट्रोलर क्या होगा कि यू विल राइट डाउन द कोड इनटू अ सॉफ्टवेयर, and then you put the software into your machine and it starts working according to the program. So that is called computerized numerically controlled machine. What would the features of a computerized numerically controlled machine? That it can store more than one part program. Okay, so you can have different programs which are fed into your machine, and you can select any of the program to carry out the processes. Something like, let's see, अगर आपको यहाँ पे हो कि आपने एक slab बनानी है, so this is part 1 program which is going to make you a slab of certain directions. दूसरा क्या हो सकता है, you want to make a disk, so this can be another program. So you can have more than one programs which are stored into your machine, and then you according to the need, if you want to make a disk, so run the program number 2. If you want to make a slab, run program number 1. Okay, then there can be various forms of input, ठीक है, which can be with the help of numerical controlled है, तो आपके पास प्रोग्राम इनपुट के लिए आप we use एक मशीन के ऊपर ही, एक तो हम सॉफ्टवेयर पे प्रोग्राम कर सकते हैं, और एक मशीन के ऊपर there is a term written as MDI. This is manual data input. So with the help of this is online programming. The MDI is actually online programming. And while using the computers, you can program offline. So offline में क्या होता है कि your one program is running. Let's see, आप slab बना रहे हैं, and then there is a requirement to make a disk. So you do not need to stop the machine. You can now go back to your PC. You can write down the program of disk. By that time, the slabs are being made, and when the slabs are over, you pick up this program, put it in your machine, and run it. And then you start making disks. So that is offline. So offline would help you in carrying out the manufacturing with a higher production rate. ठीक है? At the same time, जब आप manual data input करते हो, तो आप manually program करते हो, then you make one sample and see if it is made correctly. जब आप offline programming कर रहे होते हो, तो you can use the simulators. You can run those programs on simulators. You can crack those on simulators, and then you put them in the machine. So the program editing जो है ना, that can be done in both the cases, but offline and online. Then you can fix कर सकते हो cycles की programming and subroutines, that this cycle is to be run for how many cycles. So वो जितने cycle चलेगा उतनी ही वो आपको बना देगा, parts बना देगा. Then you can carry out interpolation. We know this can be acceleration and deceleration of the computation. ये भी आप कर सकते हो. And then there has to be a communication interface between the two, either your computer with the machine control unit, then the machine itself. So if we look at the computerized numerically controlled machine in a graphical form, so it means that there is a system bus. So मैं computer की terminology थोड़ी सी use कर. So there is a system bus. The system bus is a wire on which the program of instructions, they move from one place to another. So you can now see that you have a memory in which you have your part program. See, you have a memory on which you have a part program. That program is moves onto this. So it goes to the machine control unit. Okay, it goes to the machine control unit, जो कि position या spindle का control है. Then इसकी एक terminology ये जो है CPU. So ये, I mean, the CPU and machine control unit, these can be one thing also. ठीक है, ये जरूरी नहीं है कि ये दो अलग-अलग चीजें हों, but just to show you कि machine control unit है, फिर एक central processing unit है. ठीक है, so ये तमाम instructions जो यहाँ पे आ रही थी, वो these are being processed here. Then there is a sequence control. So whatever instructions जो कि यहाँ से part program में बनी थी, उनका एक sequence बनने के बाद उस sequence में उन्होंने execute होना है. And then these are the input or output interface, जो कि it can be an operator panel जिसमें आपको वो नजर आ रहा होगा, और it can be a tape reader. Tape reader, मैं tape की जो बात करूँगा कि there used to be, before writing down these G and M codes with the help of alphanumeric data, there used to be tapes. ऐसे लंबी tapes होती थी जो कि आगे रोल पे ऐसे रोल पे चढ़ी हुई होती थी, रोल्स हुआ करते थे. और then there used to be some punchings. ठीक है, और ये इस तरह, और ये जो पंच है, ये जो सुराख है, एक्चुअली द मशीन कंट्रोल यूनिट used to read this. जैसे अभी मैं बात कर रहा था कि आप जी और एम कोड की फॉर्म में एक प्रोग्राम लिख सकते हैं टू मेक समथिंग। उसमें ये प्रोग्राम इस टेप के ऊपर लिखा जाता था और इस टेप को जब मशीन पे लोड करते थे तो द न्यूमेरिकली कंट्रोल मशीन, कंप्यूटराइज्ड न्यूमेरिकली कंट्रोल मशीन यूज्ड टू मेक द पार्ट फॉर अस। ये टेप रीडर्स एंड देन उसके बाद हम टेप रीडर से मूव करके हम जी एंड एम कोड में सॉफ्टवेयर की फॉर्म में आ गए। ये कंप्यूटराइज्ड न्यूमेरिकली कंट्रोल मशीन जो है ये उनकी एक एवोल्यूशन है। ठीक है जी, हम ये पढ़ चुके हैं, हम इसकी डिटेल में नहीं जाएंगे कि ये एक टर्निंग ऑपरेशन है जिसके अंदर डेप्थ ऑफ कट जो है वो एक्स एक्सिस में लगाया जाता है और जो मूवमेंट है टर्निंग की वो वाई एक्सिस में होती है। ठीक है, इसके ऊपर हम कोई डिटेल में और मज़ीद बात नहीं करेंगे। सिमिलरली ड्रिलिंग मशीन या मिलिंग ऑपरेशंस हैं, ये भी हम बात कर चुके हैं कि ये कौन कौन से एक्सिस में कैरी आउट होते हैं। दिस इज जस्ट अ रिवीजन कि ये कटर की स्पीड, फीड, डेप्थ, ये तमाम चीज़ें वाइल वी आर डीलिंग विद द प्रोग्रामिंग, तो ये तमाम चीज़ें हमें फीड करनी पड़ेंगी अपनी मशीन में। कैसे, वो हमें भी आगे चल के देखेंगे। Carry out any operation, we need to put in all these things into our program. So this is your reading assignment of your book 7.3.1. This is machine tool application. So I would request you all to please ये मेरे ख्याल में एक सफ़े या 1.5 सफ़े की टोटल एक रीडिंग असाइनमेंट है। सो प्लीज़ read it through. In fact, this gives you the idea of selection of the speed of rotation of your tool according to the feed, according to the material. तो आप ये पढ़ेंगे, so you will come to know that how the speed of the machine, the rotation of the cutter or the rotation of the work part is set, keeping in view different parameters. ठीक है, so this is your reading assignment. All right, now where the NC machines are most appropriate. Okay, we know this, we already talked about it a lot. So it is good for batch production, good for repeat orders. So it is good for batch production. So you can, how batch production? So you can set the cycles to be repeated. ठीक है, तो बैच बन जाएगा। रिपीट ऑर्डर्स, यू हैव प्रोग्राम 1, प्रोग्राम 2, program 3 of different parts. So whatever order is given to you, so let's see order number 2, so you can just run this program. You can take care of complex part geometries, हम इसके ऊपर बात कर चुके हैं। Much metal needs to be removed from the starting work part. So क्या अगर आप ज़्यादा मेटल को रिमूव करना चाहते हो तो आपको बार बार एक ही केस, एक ही मूवमेंट को रिपीट करना पड़ेगा। हम मैनुअली भी करते हैं, बट दिस कैन बी डन विद द मशीन। देन मेनी सेपरेट मशीनिंग ऑपरेशंस ऑन द पार्ट। सो क्या मतलब एक ही मशीन के ऊपर यू कैन कैरी आउट मोर देन वन पार्ट, मोर देन वन ऑपरेशन विद द हेल्प ऑफ, लेट्स सी, मिलिंग मशीन में आप गियर कट कर सकते हो, मिलिंग मशीन में आप ड्रिल कर सकते हो, मिलिंग मशीन में आप मेटल रिमूव कर सकते हो। ठीक है, definitely the part would be expensive because the machine cost will also be included. Machine cost will be included in the part price. So characteristics हैं कुछ, हम इनको बारे में पहले भी डिस्कस कर चुके हैं. This is just a repetition for you. Advantages हैं, you can just go through this. So क्या है, non-productive, time is reduced. ठीक है, सो मशीन की सेटिंग और वो चीज़ें वो आपको करने की जरूरत नहीं, मशीन इज सेट। ये बड़ा इंपॉर्टेंट है, एक्यूरेसी एंड रिपीटेबिलिटी। सो दिस इंक्रीजेस क्वालिटी, दिस इंक्रीजेस क्वालिटी। ठीक है, देन लोअर स्क्रैप रेट्स। सो चूंकि आप प्रिसाइज काम कर सकते हो, प्रिसाइज वर्क कैन बी डन। सो आप, इसका मतलब ये हुआ कि इफ यू वांट टू मेक, let's see, a slab of 2 inch by 3 inch. So since you can precisely make this slab, तो इसका जो raw material है वो आप, ज़रूरी नहीं है कि वो आप ज़्यादा बड़ा लें. So you can just take 2.1 इंच एंड 3.1 इंच, और रादर इससे भी कम 2.5 इंच का भी 2.02 इंच का भी 2.05 इंच का भी ले सकते हैं, क्योंकि यू हैव अ प्रिसाइज मूवमेंट विद द हेल्प ऑफ योर मशीन, और यही प्रिसाइज मूवमेंट डेफिनेटली यू विल हैव अ लोअर स्क्रैप रेट, क्योंकि ये कम से कम आपका स्क्रैप या ये मटेरियल कट होगा। देन इंस्पेक्शन, चूंकि प्रिसाइज है तो इंस्पेक्शन की रिक्वायरमेंट भी कम हो जाएगी। कॉम्प्लेक्स पार्ट्स हम बना सकते हैं, ये भी हमने वी हैव टॉक्ड अबाउट इट। इंजीनियरिंग चेंजेस, पर ये एक्चुअली इंजीनियरिंग चेंजेस जो हैं ये दीज आर रेफर्ड टू एज द कॉन्फ़िगरेशन ऑफ मशीन।
सर आप give-
जी बताइए। आई एम सॉरी, आई डिड नॉट get your question. Is there a question? No, I think somebody has just switched on his mic. So kindly, I would request if you can just switch your mic off, because this is a little disturbance in the class. Okay, thank you. So we can use the simpler fixture. We can have a shorter lead times. We have talked about the lead time. So shorter lead time means that coming the raw material into the factory and the finished product going out. So that will actually will be a shorter lead time to make some product. And then operator skill level requirements are reduced. So अब ये बड़ा एक important है कि you need to have a skilled labor to program your machine. So जो प्रोग्राम लिखने वाला ऑपरेटर है, he has to be skilled. लेकिन मशीनिंग करने के लिए आपको स्किल नहीं चाहिए. So the skill level है for the machinist वो reduce हो गई है, because that is being done with the help of machine, and that machine is being controlled with the help of a code. और वो कोड में जो कंप्यूटर ऑपरेटर है वो या जो प्रोग्रामर है उसकी स्किल सेट जो है वो अच्छी होनी चाहिए, एंड यू डू नॉट नीड अ मशीन ऑपरेटर टू हैव अ स्किल रिक्वायरमेंट. ठीक है, सो ये एडवांटेजेस हैं सीएनसी मशीन्स के. डिसएडवांटेजेस क्या हैं? इट इज गोइंग टू हैव अ हायर इन्वेस्टमेंट कॉस्ट. We have talked about it earlier, so though we are not going to go into detail. The part programming issues. So part programming के लिए आपको एक skilled programmer चाहिए. अगर उसने प्रोग्राम गलत लिख दिया, so your whole batch will be discarded, will not be passed by the quality control. ठीक है, so the programmer has to be skillful, and then is the higher utilization requirement. So if you are going to put in a CNC machine, so it has to be utilized for a larger amount of time so that it pays you off. Otherwise उसकी जो cost है investment की, जो price है machine की, वो फिर that would lead to increase in the cost in the selling price of the product. So that has to be taken care of as a disadvantage of CNC machine. Alright, we come on to the part programming now. So I would need your attention here, so that okay, then we have a break here for let's see, for 5 minutes. So I would request you all to be back after 5 minutes. At the moment we have how many people on board? Alright, we have 19 people on board, so I would request you to please come back, or if you want to just keep silent for 5 minutes. So I'll take some voice rest in this time, and I'll stop the recording here, so this your